Alright, in this video we are going to talk about conditional probability. The conditional probability of an event B given an event A, using this notation, probability of B given A, is equal to the probability of A intersect B divided by the probability of A. Alright, so that's how we formally define conditional probability. Now this formula right here gives rise to another formula. So if I multiply both sides by the probability of A, both sides, then what we end up with is the probability of A times the probability of B given A is equal to the probability of A intersect B. Now this is very useful when you're given a problem that has conditional probabilities and you need to find the intersections of probabilities. And it's best shown with a tree. All right, so I'm going to outline a tree that utilizes this formula to help solve problems. So the first step of the tree is you have to be given the probability of one of those events. Well, so let's say we were given the probability of A. All right? So if we're given the probability of A, we know the probability of not A. Right? That's just 1 minus the probability of A. All right, so our next line on this probability chart is going to be the conditional probability. So along this first line, this A line, so now we're going to look at the next event, the probability of B, given that we traveled along this line, that is, that A occurred. Or we could have the probability of not B happening given that A occurred, right? Those are the two things that could happen given A. Well, likewise, we can construct this set of branches. So this is assuming the A complement has occurred. So what we now want is the probability of B given that A didn't occur, and the probability of not B given that A didn't occur. So those are all the possibilities of two events occurring in this conditional sense. So look what happens if we multiply along these lines. So if I multiply along this line right here, that is the probability of A times the probability of B given A. Now if you look up here, that's exactly the probability of A intersect B. Okay, if I multiply along this next line, so probability of A times this, so it's the probability of A times the probability of not B given A. Well, just replace all of your B's with B complements, and you really have the probability of A intersect not B. Okay? Now, let's go down this line. So this is assuming A complement has happened. If I multiply here, it's the probability of not A times the probability of B given not A. So this is like this formula up here, except replace all your A's with A complement. So you really have the probability of not A and B. And I think it should go without too much saying. This is the probability of not A, ooh, that yellow is bright, times the probability of not B given not A, which gives you the probability of not A and not B. Okay, now I'm going to draw a little Venn diagram here. Let's erase that, stray marks, and see what's actually happening. Okay, so we have an event A and we have an event B. I'm going to color code these. So this one right here, A and B, is this. The blue one, A and not B, is this, right? So that's the stuff that's in A but not in B. Not A but in B is this other part. And then this kind of painful yellow is not A and not B, which is all the stuff out here. So that's all possible things that could happen. And they're all disjoint. Now notice, if what I wanted was the probability of B, I probably shouldn't use that color. Let's use a different color altogether. We'll go back to black. Okay, so the probability of B is equal to this purple plus this green. So it's equal to the probability of A complement and B plus, and the green, the probability of A and B. So it's really just taking B and breaking it up into when the event A happens and when A doesn't happen. All right, so if you're given all the information to create this chart, you can actually find the probability of just B from the chart. We'll stop there.